Hey Algebra 2, I want to do today's lesson on my computer so you can kind of see what's going on when I do the Desmos activity in our notes. So it says on our notes here that since quadratic functions can be given in the form f of x equals ax squared plus bx plus c, let's see if we can find a different form of a quadratic function that gives us more direct information about the parabola. So the first thing it asks us to do is type in y equals x squared. And what do you notice just starting off the bat here? Where is the vertex of this parent graph? Well, the vertex in this case is at 0, 0. The next thing it asks us to do is type in a different box, y equals a outside of x minus h squared plus k. And now we need to add sliders for these. So what this is going to allow us to do is when we write it in this form, we're going to adjust the sliders to see what happens. So the first slider we want to adjust is h. If we adjust h up to 2, what do you notice has moved? Let's actually put everything at 0 that's, nope, not that one, sorry. Let's leave that at 1 where it was. But let's move k back to where it belongs at 0. So if I move h, what does it do? It actually moves the vertex from 0, 0 to 2, 0. So adjustments in my observations box, I'm putting adjustments to h, move our vertex x coordinate. Okay. Now the next one asks us to, let's move this back. Let's put this back at 0 so it becomes our parent graph again. It says we want to move the slider k and we want to move it all the way over to 3. When we move our slider to 3, now where has the vertex moved? Well, it's moved up to 0, 3. So in my observations box, I'm putting adjustments to k, move our vertex y value. So anytime I move that number out and back, it's going to move it up or down. And notice if it's a plus k, it's going to move it a positive direction. If we go back to our h for a minute, you'll see that as our h increases, it moves to the right, even though there's a negative in this box. So if our h becomes negative, it moves in the negative direction, even though there's a negative in this box. So this one's the kind of tricky, confusing one. So this next one asks us to move our k to 3. So I'll put it back where it was. And it asks us to move our h all the way over to 7. Notice when we're in this form, we immediately can see that it has moved our vertex over to 7, 3. So if we move our h and our k, we know what our vertex is instantly. Here's the tricky one though. If we put this, if we want this to stay at 3, we want this to go back to 1. I'm on my next box that says y equals 2 outside of x minus 1 squared plus 3. Now we are adjusting the a. And a is the number out in front of my x squared. So if I move this to 2, notice what is happening as I increase it. It becomes skinnier. So the vertex stays at positive 1, 3. But the graph itself becomes skinnier. Just writing that in our observations box. And finally, if we move it backwards and we move it down to negative 1/2, notice not only, I've gone too far. Not only has it flipped it over, instead of being a happy parabola, now it's a sad parabola, it's also increased the width. So by adjusting that -1/2, it increases width and it flips it over what technically is the x-axis. So flips parabola upside down, however you want to say that. Notice the vertex didn't change. All that changed was the physical movement of the graph to the bottom. So in summary, we notice that changing our h is going to change our x, in how far our vertex is in the x direction and our y direction. Changing our k adjusts how far up or down it goes, and adjusting our a value out in front adjusts not only the width, but also which direction my parabola is facing. So let's write each equation in the form a outside of x minus h squared plus k. And then we're going to name the y-intercept, the vertex, the axis of symmetry, and the direction of the opening for the graph of each quadratic equation. So I'm going to get rid of all this just because I don't want to switch over to my physical notes. Now I'm going to show you which problem we're working on here. How do I write this as that form? Well, I noticed that it wants me to leave this value out back, and all it actually wants me to change is my x's. So I'm going to move over to a different piece of paper just so we can see how I'm doing this math. Let's pull up a notebook here quick. So I've got, excuse me while I get everything together here. I've got this equation, I'll just write it here, x squared plus 4x minus 3. In order to get it into the form that we want it in, we have to actually use our knowledge about completing the square, because it's the only way we're going to be able to write this with this piece unsquared. So I'm going to start by moving my 3 to the other side, and I'm going to make this x squared plus 4x plus that little blank equals 3 plus the blank. Why am I doing this? Well, bear with me, we'll see in just a minute here. If I turn this into a perfect square trinomial, I replace this box with a positive 4 on both sides. That allows me to write this side as x plus 2 squared equals 7. Now, if I just adjust slightly and move the 7 to the other side, x plus 2 squared minus 7, it's now in the form of a outside of x minus h plus k. Our a in this case is just 1 because we didn't have a number out in front here in the first place anyway. Our h is now going to be -2, and our k is now going to be -7. So now we can graph this without actually doing all of the work from before, because knowing these pieces, we now know that our our x value has moved to -2. Our y value of k has moved to -7. So if we jump back here on the graph and put it in that form, if we say f of x equals x plus 2, I have to square this little piece, squared, minus 7, if we did it right, you should see that these graphs are going to line up. So we've written this same equation, just in a different way. So these two forms are equivalent. Knowing this, I can now put my vertex at -2, -7, just like I said, because if I know my h value and I know my k value, put it -2, -7. I'm just doing it on my physical copy of my sheet, so I have a note of that. And then notice, because there's no a value here, we're not really worried about how skinny or how wide the graph is going to be. So we just do a quick sketch. Notice slope here is over 1 up 1. And then if we wanted to find the intercepts, we totally could This one's not going to be real nice, neither is this one, but I can really quickly find my y-intercept and then obviously just reflect that over my axis of symmetry like I'm used to. You'll see that one falls at -4, -3. So we're going to use the same tactic almost every time. So if we hop on the back, I'll show you how to rewrite one of those, and then I'm going to leave the rest of the notes to you. So I've done a little behind the scenes work real quick off camera just to set this up. So I've got my preliminary graph here, and I'm going to show you how to rewrite this as a different form. So the first thing I'm going to personally do is I'm going to move that 2 out front. This allows me to just have my x squared plus 2x term that I will be able to write as a difference of squares problem. I'm going to leave that 2 out there for now. And how do I separate this into a difference of squares? Well, I need to write x squared plus 2x. We move the 0 to the other side, and then we need 1/2 of 2 squared. So it's going to be +1 on one side. It's going to be +1 on the other. And then if I rewrite just this specific portion as a difference of squares, I will need to rewrite it as x plus 1 squared. And then, of course, I'm going to bring that +1 over. So I'm going to have 2x plus 1 is 2 times x plus 1 squared minus 1 is the same. So I'm going to go over here quick, put that in, and say 2x plus 1 squared minus 1. I'm sorry, minus 2. Because when we multiplied by 2, I forgot that I had to also multiply this one over here. So my apologies on that. But this is the rewritten version of the form above. And as you notice, they're going to overlap. So I go to my sheet, I write that down, and then I can find the vertex. It's going to be at -1, -2. And this one's going to be just a little bit skinnier. Instead of having a slope between my pieces here of over 1, up 1, now I'm going to have to go over 1, up 2. So as you can see, this form, while equivalent to our normal standard form that we're used to, this one can be really, really useful in showing us the vertex. I'm going to leave you to the last few. Let me know if you have any questions.